Most Power Query solutions seem rock solid, right up until someone sends you the following month's report. Today we are running a crash test. I have one query and 5 increasingly broken reports. Will it make it all the way to level 5? Let's find out. Let's start easy. Here is a report where the header starts after 2 rows of junk. Nothing unusual. We can simply remove the first 2 rows and promote headers. And done. The query works, the table looks clean, level 1 cleared. But don't get too comfortable, because this solution is already hiding a dangerous assumption. We assumed the header always starts in row 3. That happened to be true in the first file, but now the header starts in row 6. The good news is that we don't actually care whether the header starts in row 3, 6 or row 20. We only care where the real header begins. So instead of hard-coding the number of rows to remove, let's detect the header dynamically. The function we are already using is table skip. What's interesting is that its second argument doesn't have to be a number, it can be a condition. So we can tell Power Query, keep skipping rows until column 1 is client. That's a tiny change, but now the query adapts automatically. Let's test it. Level 2 cleared. Unfortunately, there is another assumption hidden in our query. Let's move to the next dataset. Refresh and broken again. We assumed the table always starts in column A. Not this time. The entire table has shifted to the right. Apparently somebody moved the entire table 4 columns to the right. Why they did that? We have no idea. But we already know where the header row is. Now we need to know where the table starts horizontally. In other words, where is the top left corner? Let's reuse our anchor, client. First we need to grab the detected header row. I convert the table into rows, so I can inspect them one by one. And to do it properly, we will use list transform function that allows us to check each row for a condition. We just need to find the list that contains the word client, our anchor word. So let's try it out. You can see the true value in the row number 6. And to find the number of rows we need to skip, we will use list position of function. The second argument is true. And now we need to find the number of columns to skip from the left. To achieve this, we will use a similar approach. We can just take the header row and find the position of the word client in it. When we know the horizontal and vertical positions of our anchor word, it becomes much easier. We can use table skip once more. To remove the unneeded columns, I will use table remove columns function and make the list dynamic. I need a list of columns to remove, so I will use list first end function and make the list dynamic. Table column names from the previous step. We already know the number of columns to skip. It works. The table can move down, the table can move right. Not bad. And our query survives. Level 3 cleared. But we are still trusting something we probably shouldn't. Time for another trap. Let's refresh, and the result isn't correct. We also assumed the client appears only once. That was true before. But now we have a fake header a bit higher up in the file that also contains the word client. Our anchor is no longer unique, and if the anchor isn't unique, our detection logic can easily lock into their own row. So let's stop looking into a single header name. Instead, let's look for multiple header names together. For example, client and sales agent. If a row contains both of them, there is a much better chance we've found the real header. The code change is surprisingly small. Replace list contains with list contains all, and instead of searching for one value, provide a list of expected header names in figure brackets. The nice thing is that this is easier to maintain too. Need another validation check later? Just add another header name to the list. So let's test it. Refresh and correct again. Level 4 cleared. Still one challenge remains. Let's see if the query survives the final boss. Refresh Almost. The table is detected correctly, the header row is detected correctly, and everything is aligned correctly. But now we have repeated headers inside the data. Apparently one header wasn't enough. So we assumed the header appears only once. Fortunately, our query structure is already doing most of the work. After promoting headers, those repeated headers become ordinary rows. And that means the fix is actually very simple. Just filter out rows where client equals client. Sometimes the solution isn't about writing some complex logic. It's about noticing that most of the problem has already been solved. So let's test it one final time. Refresh, and level 5 cleared. If you've watched this far, here is the reward. Our query survived 5 different datasets. But do you really want to rebuild all this logic every time? Probably not. So I wrapped everything into a reusable function. It already contains the same ideas we've used today, plus a bit of extra error handling. Now, whenever I import a messy report, I simply call the function, provide the required arguments, and let it do the work. One click, and done. Much nicer than rebuilding the entire solution from scratch. I've included the file in the description, so you can use the function as is, modify it, or take on the extra challenge included in the workbook. The real lesson today wasn't really about header detection. It was about assumptions. We started with a query that worked for exactly one report, and then we discovered 4 hidden assumptions. The header is always in the same row, the table always starts in the first column, the anchor name is unique, and the header appears only once. I remove those assumptions, and suddenly the same query becomes much more resilient. So here is the question. What assumption in your Power Query solutions has come back to bite you the hardest? Let me know in the comments. See ya!